Welcome to the last video from the third lecture, which is devoted to conditional probability. And in very simple terms, conditional probability is probability you calculate keeping in mind some prior information. So we will consider the following example. So we have doctors and nurses in the hospital, and they are males and females. So we know that there are 90 male doctors and 90 male nurses, which gives us 180 males in total, 100 female doctors and 20 female nurses, which gives you 120 females in total. At the same time, we have 190 doctors in total. 90 of them are male and 100 of them are female. And we have 110 nurses in total. 90 of them are male and 20 are female. So, we know that probability that a randomly picked person is a nurse is 110 divided by 300. We know that probability that a randomly picked person is woman is 120 divided by 300. Also, we know that probability that a randomly picked person is a nurse and a woman is 20 divided by 300 because we have 20 female nurses, as you can recall from the table we've just discussed. So I believe it's perfectly clear for you because here we already discussed what you already know, and now we can actually introduce the notion of conditional probability. So this is how you denote it, and this is how you read it literally. So this is a probability that a randomly picked person is a nurse, provided that this person is female. So you remember at the beginning of this video, I told you that conditional probability is all about probability you calculate keeping some prior information in mind. So in this case, we have this prior information. We know that person is female. And based on this, we have to figure out that this person is a nurse. And this is the formula. So conditional probability that randomly picked person is a nurse, provided that this person is female, is equal to the probability that randomly picked person is a nurse and female, divided by the probability that randomly picked person is the female. So we literally use this formula every time when we calculate conditional probability. So based on this, we can calculate it. If we know that this person is female, we know that probability of a randomly picked person being a woman is 120 divided by 300. So here we have it. Here we have it. And we know that there are 20 female nurses. So 20 people out of 300 people fulfill both the conditions. They are nurses and they are female. So here we have it, this intersection. And finally, we can just divide the upper part by the part below, and we get approximately 16.7%. So the conditional probability that randomly picked person is a nurse, provided that this person is female, is approximately equal to 16.7%. However, you shall keep in mind that conditional probability that randomly picked person is a nurse, provided that this person is female, is not the same as conditional probability that randomly picked person is a female, provided that this person is a nurse. Formula will be different. Okay, So now we will calculate conditional probability that randomly picked person is female here, provided that this person is a nurse. So we will apply the same formula. Again, upper part will be just identical because we're still interested at the probability of intersection of set N and F, or the probability that a randomly picked person fulfills two criteria simultaneously, being a nurse and female at the same time. So here, this part is identical. However, now we have to divide by the probability that randomly picked person is a nurse. And you can recall that this is 110 over 300 because out of 300 of personnel, 110 people are nurses. So when we calculate this, we get approximately 18.2. So we can conclude that conditional probability that randomly picked person is a female, provided that this person is a nurse, is approximately equal to 18.2%. So that was it when it comes to conditional probabilities and our introduction to probability theory lecture. Hope you enjoyed it and see you in the next lecture.